I'm going to be solving the 2009 AMC 10A problem 24. Let's read through the problem. 3 distinct vertices of a cube are chosen at random. What is the probability that the plane determined by these 3 vertices contains points inside the cube? So the first step in this problem is to draw out a pretty basic cube. So this is going to be our cube. Okay. And let's label these vertices. So I'm going to call this one A, B, C, D, E, F, G, H. So the question's asking for the probability that the 3 vertices we select, if we draw a plane through it, there's going to be some points inside of the cube. So first, let's just do the easy part and determine the total selections of 3 vertices. Since we have 8 distinct vertices and we want to select 3 distinct vertices, it's just going to be 8 choose 3, which is equal to 56. So our total number of ways is 56. Now looking at this question, there's really only 2 types of planes we can have, and that's like what I'm going to call a surface plane. And so what I mean by a surface plane, an example of it would be like if we selected A, B, and C, or if we selected F, G, and H. And the reason I'm calling those surface planes is because they just kind of skim the surface of the cube. Then the next kind we can call interior planes. And those are going to be planes like, those are going to be what we want in the question. The ones that go inside the cube. And so an example of that would be AHF. And another example of this would be BDG. So one way that we might start this problem is by saying, okay, so since we want interior planes, let's count which ones there are. So we have AFH, we have ACH, we have CFH. So there's a lot of them clearly, and they're not very easy to count. So I'm going to use a method called complementary counting, and so just counting, which is basically just counting first the ones that you don't want, like the cases that you don't want, and subtracting that from the total. And in this case, since we only have surface planes and interior planes, if I can calculate the number of surface planes, which is much easier to do, and I can subtract that from the total, which is 56, that'll give you the number of interior planes. And so the number of surface planes, if we just select like a certain face, so we have 6 total faces. So first, what we don't want. So yeah, we have 6 faces. 6 faces. And on each of those, there's 4 choose 3 ways to choose a surface plane. For example, on the top face with vertices A, B, C, and D, we can have ABC, we can have ABD, we can have BCD, or we can have ACD. So there's 4 choose 3, which is equal to 4 surface planes. 4 surface planes. And since there's 4 of them on each of the 6 faces, there's a total of 6 times 4 equals 24 surface planes. I'll just call them SAs. So now we have 24 of what we don't want, and we have 56 as our total. So to find out what we do want, which are the interior planes, we do 56 minus 24, which is equal to 32, and we divide that by our total. So 32 divided by 56. Dividing both the numerator and denominator by 8, we get 4 over 7. And so 4 over 7 is our answer, which is C.